So when I'm looking at this polynomial graph, I'm noticing that it probably has an odd degree because of the way the long run behavior is. It's not an even powered function. Looks like a parabola or an upside down parabola, and I'm seeing something that's a third degree. I'm also seeing these roots. I'm seeing it crosses at -2. I'm seeing it crosses at -1. Then again at +2, then again at +4, and I'm noticing that the graph kind of bounces at +4, so that tells me that it's a higher multiplicity than 1. So I'm gonna guess that it's 2, and then the other thing that tells me is that if I have 1, 2, 3, 4, 5 roots, that confirms my long run behavior idea that it's going to look like this. Okay, so now what we got to do is we need to write the these roots as factors. So you're just going to solve each of these. So that's equal to 0. That's equal to 0. That's equals to 0, and the add x equals 4. We're going to put a multiplicity of 2. Okay. So the other thing we're to look for is that it goes through the other points. I'm also seeing the one other point that I'm noticing on this graph is that it has a y-intercept of 4. So what I did is I replaced, just to check and see if I was right with my equation, if I had to do anything more with it, I substituted in 0 for x, got 2, a 0 for x there, I got 1. 0 for x there is -2, and a 0 for x there, it was -4, but square it, you get 16. Well, that certainly isn't equal to 4. So that must mean there's some kind of stretch factor going on in front. So I set up an equation. I said 4, the y value, is equal to some stretch factor times, I'm replacing x with 0 because, I'm hoping you understand that the coordinates at this point are 0, 4, right? And that's why when x is 0, y is 4. So that's why we replaced the y with 4 and 0 in for all these x values. So you solve this equation. Ended up with that. Divide both sides by -64, which simplifies to -1/16 is our stretch factor. So I graphed this function out at Desmos, and I'm noticing that it has all the key features: the y-intercept, those zeros with a multiplicity at x equals 4, so it looks like I came up with this correctly. You do not have to expand these polynomials out to keep my open math out happy. So I hope that helps.